second part of this video is talking about the subset, superset, and the power set. There's numbers of the concepts that we may distinguish together. So let's go to the free plan. So I closed this just now. So let's go to the latest one. So the latest one is this one. You can see if you don't save that, it will have auto store. So first is what's the subset? If S is a subset of T, so S and T both are set, only if all the members of S are also members of T. So we use S underscore subset to check whether it's a subset. A set T is assigned to be a superset of another set S if T contains all the members contains in S. So subset and superset are inverse relationship. We use S underscore superset to check that. The power set of our set, so let's not give the space, is the set of all possible subset of S. So we will see the power set. We already see that in the PowerPoint. Use len to find the cardinality. We already do that. S underscore proper underscore subset or S underscore proper underscore superset will give you the whether it's a proper subset or proper superset. So let's see from the book. Let's continue use the Python's this interpreter. So let's from SymPy import finite set. Oh, so I use typo. And then S is finite 1, so it's just one element. T is finite 1 and 2. So we can see S dot is subset T is true. T dot is subset S is false. But then is we say T is superset S. That is true. S definitely is superset T will be false. And S is subset S will be is so is dot is true. So T is subset to T is also true, and T is superset T. So always true. So if you put that to the self, it will always superset or subset true. And what the power set? So let's see, S is finite 1, 2, 3, and then this we put is just S dot power set S. You can see here we got our even empty set is the subset of S, and then 1, 2, 3 the single element, and the 3 possibility of the 2 element, and his itself 1, 2, 3. So all those are the superset of S. So if I put this more, so you may get that is longer. So because that have the more kinds of the combinations, and the len S will be the always you remember we should have the distinct element. So that is 4 distinct element, and then the we will see this proper. So S is 1, 2, 3, 4, 5. T is 1, 2. So now T is vice versa. Is subset S true. Is T is proper subset S also true. So what's that definition is S is a proper subset of T only if all the members of S are also T. And T has at least one member not in S. So we use T and S is just reverse. But now you can see S at least has two, at least has one. So we have two elements, 3 and 4 are not belong to T. But all the T's elements, 1 and 2, are belong to S. So that means they are those are the proper. So if I put is S is equal to T, so S is also 1 and 2, and now is S is A subset T is true, but is proper subset T, well, false. So proper is means you need at least have one different distinct value compared to another one. So that is the those different relationship between two sets. And here is a common number size, some discussion. I would like that you can have some read from this book. I will not touch base on that. So given this is we have putting our discussion on finished on these two parts. First is a set construction, including the definition and the history of sets theory. And then we talk about the different relationship as a subset, superset, power sets, and also proper subset, proper supersets. So now I hope is with those you got enough the knowledge on hand for the sets and the sets related concepts. Let's close this, and the next video we will talk about the operation. So how we can union the side, how you can minus from one side by another side, and how to do the product, the operation. So see you in next video. Bye for now.